Alrighty. Hey, well, we're taking a break from the usual programming streams to do a programming adjacent stream. So we're going to play Shenzhen I. This is kind of on theme with Cinecore in that we'll mostly be writing assembly. Give me a sec to get situated here. Alrighty. So, I only know the basics of this game, and it's that we are role-playing an engineer from the States who is disaffected with her career and has decided to move to Shenzhen and found work there, programming hardware. The cool thing about this game is that there are, it comes with a manual. So there's this right here. And it's a thick manual. In fact, the way they recommend you play it is by printing off the whole thing, put it in a binder, complete with the tabs and everything. I don't have that with me yet, and that's pretty hard to share on stream. So what we're doing is just having a PDF up on screen occasionally as we're looking through it. But I'm going to start in the game. And yes, we have an OS. We have email here. Dear new employee, thank you for joining Shenzhen Longteng Electronics Company Limited. We aim to become a world-leading company in the electronics industry and a respected brand with products in homes, offices, and public spaces across the world. Longteng Electronics was founded on the following principles. 1. Diligence. This means both diligence in your work and diligence in your life. When you encounter a problem, do not give up. Even if you are not talented, by working at it every day, little by little, you can achieve the goal. Okay, I respect that. 2. Connections. The process of creating electronics is a process of creating connections between different components. In the same way, we do business by making connections with other people. Therefore, it is important to always be making connections in your work. Okay, a little bit cheesy, but fair enough. And, oh boy. Salubriousness? Salubriousness. An unhealthy mind creates an inefficient design. An unhealthy body builds a defective product. Follow correct eating, correct behavior, and correct thinking in order to maximize your potential. Please keep these principles in mind as you contribute to our efforts. Salubriousness. You know what? I'm on board with that. Healthy body, healthy mind. And what is correct behavior? Correct thinking. I hope this doesn't disclude staying up until, oh, God knows when. We're gonna keep it tight though. So no longer than 3 hours. This will be 11 p.m. to 2 a.m. Every Monday Eastern Time. And we have coworkers. Fresh meat. Just kidding. Welcome to Southern China. It's all right, I suppose, except for the heat, smog, and the lack of decent cheese here in Shenzhen. Still far better than any engineering gig I can find back home in the UK, though. I'm assuming you end up here for similar reasons? Yo, so I heard you're our newest ace engineer who's going to kick ass and take names, am I right? You've probably heard all about me already, but I'm the product guy who loves to find amazing opportunities and make deals happen. Let's do this. Okay, we have a product manager. A colleague of some sort. Greetings and welcome to the team. As you've already been made aware, we are on We are on a major international expansion effort, and we're very eager to bring your skills and expertise to our company. Oh, VP of Product reaching out. My name is David. I can't read the Chinese, and I was brought to help Longteng with its internal push. I've only recently moved here from San Francisco, where I should point out there's a very vibrant Chinatown. I'm really loving it so far. It is truly fascinating to see a culture at once so ancient and so modern from up close. I'm sure we will be working closely together to create many successful products. Yeah, I kind of like the vibe of this. Giving up on your gig and then moving to China to work there, get a fresh start on everything. Sounds kind of nice. Hello, my name is Ji Sheng. I'm the chief staff engineer, your boss. I've not managed many foreign workers before, so please understand if I make a mistake here or there. Anyhow, I will send you your first job shortly. Yi. Okay, if I'm living in Shenzhen, I suppose I ought to learn how to pronounce all those romanizations. So I've already got some homework. Okay, so let's take a look at this. Oh, from Carl, our colleague. Important, read the manual. I know you're so good at engineering, systems, and life in general, you haven't needed a manual in ages, right? Well, trust me on this one, you really want to read the manual here. Even better if you keep it handy as you work. Don't be like the non-manual using person who quit just before you started, and whose name shall never be uttered again. Okay. I did intend to read the manual, because I like reading manuals. It happens more often than you'd expect that, I don't know, sometimes you have a colleague who could have solved all their problems by reading the manual in advance. Sometimes it's just like going in and trying to figure it out as you go. Manuals are good. This product is an imitation. Okay, here's our first thing. So we have a fake security camera, fake surveillance camera. This product is an imitation mock security camera. It has two blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random, intermittent pattern to resemble a data upload. As you'll notice, the design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate your outputs, your output should match those expected values as indicated. Let the simulation run until it has passed all the test cases to make sure you have a proper solution. Okay. I'm absolutely certain you'll be better than the last person. Okay. Well, if the last person gave up halfway, we can at least not give up. Diligence, right? Diligence is one of our core values. Yeah. Okay. I think we should open the manual first. So I'll have a look. So there's a microchip family with some basic instructions. Oh, and I guess there's more story in here. Good morning, just a quick update for you today. First off, I placed your resume with 2 new agencies. They specialize in industries a little different from yours, but you never know where a match might be made. I've also reached out to a few more of my colleagues across the country, letting them know to get in touch if they hear of anything. Okay, so we have a recruiter. Finally, I followed up with Electromotive again, but they keep stalling. At this point, it's safe to say an offer won't be coming. I'm familiar with that. You've been with us for a while now, and I appreciate your trust, so I want to be honest. The likelihood of us finding something that genuinely makes use of your skills in the foreseeable future is rather low. This isn't because of any lack of qualifications on your part. It is simply a reflection of realities of the time. That sounds too familiar, actually. We'll keep trying, of course. I just want to ensure you kept some realistic expectations going in mind going forward. I know you've said you were hoping to stay in the country, but it may be time to reconsider that stance. Many of the people we represent have done stints overseas and report that it's eye-opening and in some cases career-enhancing move. I don't have a lot of contacts in that particular arena, but I can point you in the direction of someone I know who has some experience working with Chinese electronics firms. Let me know if that sounds interesting to you, and I'll get you two introduced. Okay. I would bite. Fish partners recruiting. Oh, so we fish for, they fish for employees, huh? Hey, just want to follow up on our call. As I mentioned, the company is called Longtang Electronics. They're not exactly one of the biggest players, but they've been running a stable business for a while now, and that's always a good sign. Up until now, they've mostly done manufacturing subcontracts, so traditionally, their engineering team has been relatively small, but they're looking to grow the department because they want to create new products in-house for both domestic and international markets. Okay, Longtang Electronics, so they found this job here. The position is located in Shenzhen, China, which is just across the border from Hong Kong. The pay is competitive for the area, which I think you'll find more than adequate for living here. I forgot to ask if you had family, but whatever your situation is, you'll find Shenzhen is a modern, fairly international city. There's even a McDonald's right downtown. Cool. If there's anything I might be able to do to help you feel more comfortable about the idea of relocating, let me know. I have helped many engineers like yourself find opportunities in China, and I'm pretty familiar with the ins and outs. Looking forward to hearing from you once you've had a chance to chew it over. Okay. And apparently I said yes. Ooh. Visa application form. I mean, I could fill that out. I could share some of this. I don't want to dox myself completely. I probably wouldn't share my detailed home mailing address, but I think for the sake of roleplay, I might like to fill that out. Okay. What do we have here? We have two kinds of buses. Simple I/O. Continuous signal levels from 0 to 100. Okay. Connecting to a simple input, button, switch, microphone, LED, speaker, motor. Okay. And XBus. XBus values are discrete data packs from -999 to 999. XBus pins are marked with a yellow dot. XBus is commonly used to transmit data between two microcontrollers or a microcontroller and a complex input or output, such as a keypad or numeric display. Okay. Makes sense. Simple I/O pins can be read or written at any time with no regard to the state of connected devices. XBus, however, is a synchronized protocol. Data over XBus pins is only transferred when there's both a reader attempting to read and a writer attempting to write. Fair enough. If read or write is attempted without corresponding operation on the connected device, the operation will block. Good to know. We don't want to accidentally block ourselves. Okay, well, let's take a look at this. The fake surveillance camera. Objective, create a working design for this product. Okay, so this is our CAD software. And yeah, let's open up this design. All right, so this is where the previous engineer left off. So we have two blinking lights. The network is supposed to look more random. Okay, so move 0, P0, sleep 6, move 100 to P0. So P0 here to the light, directly to the right. So 0, wait 6 seconds, 100, back and forth. Okay. And I don't know, let's... Okay, so we see the red light working and not the blue light. And here, so let's just reset to start step. I guess the step is 1 second, or is it 1 instruction? Okay, so there's 1 sleep, 2, 3, 4, and then we turn on, then we turn off, and then turn on, and that repeats. So 4 on, 2 off, 4. Okay. Let's see. I wouldn't want to do those both in here. That'd be because this has a cycle of 6 and this has a cycle of 8, so we need like 24 to get the full loop. I don't know if we can even write that much assembly. And what's going on to my cursor here? Oh. Like, how many lines of code can you write? Yeah, we're limited in the lines of code. So how do I move this? There we go. So we can just do the same thing. All right. Drag to connect. And we'll copy the same idea. So move 0 to P0. And here we sleep 4, sleep 4. Move 100 to P0. Sleep 2. Move 0 to P0. Sleep R1. Move 100 to P0. Sleep 1. And then, yeah, that's it. We start over at the top. Okay, look, the blue light's going. Looks good to me. Okay. Oh, wow. So is this? Hey, Zuno. That's right. That's right. Doing some Shenzen. I like the concept, and I kind of like the role play here. Can't find a job, so I'm moving to China. You know. Best 12 now 12. What is this here? Like, is this other people's attempts? I mean, I can't imagine doing it in, geez, fewer than 8 lines of code. Yeah, well, I'm not gonna optimize here. I'm gonna change this message though. This is not so hard. Smiling face. Fixed. Left mark. Okay, how to get out of here? And back to the email. Thank you for your prompt work on the blinking lights. Looks good. He, G, she? I'm not sure. I'll have to learn that. As you know, did you finish Shenzhen? Shenzhen days, why are we even here? Hi everyone, we've had a bunch of new signups this week, so let me reintroduce myself. I'm your host, Tilly Liu, and I run this funny little mailing list for expats in Shenzhen. Cool. I'm here to demystify some aspects of life and culture here, along with a side helping of color commentary. Sometimes just a color commentary. Yeah, I get distracted. Sparkly Dark Matter, hello, Happy New Year. Today's topic is, why the heck are we in Shenzhen? No, really, like, why are we here at all? I don't mean in the immediate sense, sure. We all have some job, some business to do. But let's talk about the large factors at play. We're here because Shenzhen is one of the fastest growing cities in the world. Isn't there like 20 million people? It's like 3 times the size of New York City for the past few decades. Ever since it's declared a special economic zone back in 1980, we're here because it, and generally the entire Pearl River Delta region, is a sprawling megacity wholly dedicated to trade, manufacturing, and services. A giant economic machine. We're here because what's possible in Shenzhen isn't really possible in many other places in the world. Certainly not at the same scale and cost. So where all this capability is headed, the future. We're going to make more stuff, more products and things until the world is buried in crap. I guess I'm asking, what is all this incredible growth for anyway? I have some ideas, but that's a topic for another day. Okay. I never had the chance to visit Shenzhen myself, but a startup I worked for 4 years, we opened an office in Shenzhen, and we're starting to do business there before the startup itself failed. But I heard good things. I'd still like to visit sometime. You start playing Shenzen and Exapunks. Yeah, I don't know if I'll necessarily finish. We'll see how dedicated I get, but certainly it's at this point it's chill, and I wouldn't mind if it got harder. Yeah, one row of puzzles left on TIS 100. Cool. Yeah, I've opened that up. I've started TIS 100, but I haven't finished. I think that one I'll play off stream. Okay, so here is a new product, Control Signal Amplifier. To view histograms and leaderboards. Okay, so our factory floor has some examples of older equipment that requires a control signal to be amplified. We had a device to adjust the signals for this type of machine, but recently it was broken. This is an appropriate project to teach you about inputs. Okay, so we're just fixing something basically. Smashed? Hang on a sec, what happened? Everyone okay? No need to worry. Very mysterious. Oh, right, yes, the Zachtronic games are famous for, or are known for having the solitaire games. Fair enough. I want to see this other email. Please enjoy a game. My daughter is learning programming. She created a simple card game. Oh, so his daughter made the solitaire game. Would anyone like to try it and give some feedback for her? I put a link on everyone's desktop. She is interested to become a game developer. Wow, Jay, that is both a lot more polished and far harder than I was expecting. Your daughter's managed to design quite a challenging patience game. Maybe there could be an undo function? She says she doesn't think it needs undo because it's actually quite easy once you develop some skill. She says get good. Okay. So we'll get there. First, let's get another win under our belt because I feel like the solitaire might actually be hard. We won't get it first try anyway. Okay. So control signal amplifier. I'm not sure I exactly understand. Control in is a simple input connected to a factory equipment. Out is also connected to factory equipment. The signal from control in should be multiplied by 12 and copied to control out. Okay. I assume then we're not worried about overflow. Macaw, Happy New Year. Good to see you. It's like Scratch. I suppose so. Yeah. Definitely, like, it'd be a good thing to show kids to get them into programming. Okay, so we have an input signal. We want this in P because the P are just like pins or raw values from 0 to 100, and the X bus is for more complicated stuff. Right click. Okay, right click deletes. Okay. What was it? We can move from P0 into a variable? I think we need to look up the manual. Okay, so there was a little cheat sheet. Maybe we could use that. There's a no up move. Alright, R. Do we have registers? Add r/i. Oh, register or integer. Okay, move register integer to register. And I assume P0 then it's also a register. We could just, I guess we can't nest these, can we? Right, when we do mul, where does the output go? Gotta scroll through the manual a bit. Your solitary game is also on Steam. That's funny. Hey, Daviddy. Yes, we are sticking on a hardware theme. Just keeping it a little bit more relaxed than Cinecore was. By the way, I did figure out how to generalize Ackermann for m=3. And I'll be happy to share that. I haven't put it in the code base, but I at least learned enough of how to solve a recurrence relation that I can just do all of them from scratch. So that feels satisfying. I'll probably revisit that at some point. Does this game require programming, computer engineering knowledge? No. And going by the emails, they say like, oh, this might not necessarily been the job you were doing before, or it's not matching your skill set, but do it anyway. I think it starts you out pretty easy. And I think it really just wants you to read the manual. This manual, by the way, how many pages is this? It's like a 50-page manual. They say to print it off to get the best experience. So I haven't done that yet, but you know, they have like binder tabs and everything. So maybe I'll do that. I'll print these off, put them in a 3-ring binder. Oh, I need to get a hole punch. When's the last time I used a hole punch? Anyway. So make sure you get enough sleep. CPUs are typically much faster than the signals they are reading and writing. Execute a very large number of instructions within one time unit. Okay, we can go to sleep, sure. Yeah, we wouldn't want to block. This generates a square wave. Okay, this is what we used for the fake security camera. Okay, and here we have some. What is act, state, and power? Because cache plus memoizing just feels lame sometimes. Yeah, it does feel like a cop-out sometimes. Like, you know those AVNA code problems where it's basically like, okay, just do it naively and then slap a memo on it. It feels like cheating. You know, like there should be a. And then some people don't memorize and they spend time trying to, like, you know, they're actually in there like trying to solve a problem, and they're probably having more fun than the people just speeding through it and writing and then make a memo. It took you 4 attempts to properly print the Xpunk sign. You know, every year, after Advent of Code, Eric will make like a thank you post and he'll mention some recommendations. I think the first time I heard of Zachtronics is probably from one of those posts. It was like, hey, you should play Factorio or a Zachtronics game. So, still kind of marginally related to Advent of Code. The following circuit is a reference design for a touch-activated light controller. When a user touches a switch, the controller will detect a rising edge. Okay, we don't need to detect a rising edge just yet, but if I can figure out some of the syntax, because we just want to multiply by 12 and then move that value. So when we do arithmetic, language reference, here we go. Okay, each line must have the following structure: label, condition, instruction, comment. Okay. All are optional but must appear in a specific order, a specified order if present. So, yeah, in this case it's just jump to end. I don't know what the plus is. Condition. Labels must first appear in one line and are followed by a colon. Okay. They're used for jump instructions. Conditional execution. Yeah, it's fair enough if it's NP hard. The Cinecore one is also interesting because you can do a bit of analysis. Yeah, totally. Yeah, it was satisfying trying to figure that out. Yeah, when I actually learned how to do it, how to solve the recurrence relation, I realized I was like very much circling around it, but just not doing the right math. Okay, so we have a label, makes sense. A conditional execution. Prefixing an instruction with plus or minus will cause that instruction to be enabled or disabled by test instructions. Okay, when an instruction is disabled by a test instruction, it will be skipped. Okay, cool. So here, this is a test equal. Check if ACC is 10. So is ACC just like a free register? We could do something like that. So let's try, I don't know, move P0 to ACC and mul ACC by 12. So it's like an accumulator. No, we'll get there. We'll get there. Let's read the manual. Conditional instructions. Registers are used as sources and destinations for data manipulated by the instructions. The set of registers valued between various models. It is an error to use a register in a microcontroller program if that register is not present. Okay, ACK is the primary general purpose register used for internal computation. All arithmetic operations implicitly use and modify the value of ACK. Oh, okay, that's how it works. So we move P0 to ACK, and then we mul by 12. And then we move ACK to P1. Cool, that should be it. Part is not sleeping. Oh. Let's see. I guess we sleep 1 second between each, and then the signal only comes in for 1 second at a time. Yeah, so after we move to P1, then we can sleep 1. Ackerman. Exactly. To me, it sounds like accumulator. Flash X. Yes. Okay, let's try this again. Cool. It looks like we're slightly off on some of these. Expected 50, actual was 100. Oh. Okay, so we have 12, 0, 50, 0, 25. Wait, we're supposed to multiply by 12. Yes? Oh, sorry, you can't see my manual. You can't see what I'm doing, can you? Okay, so here's what I wrote. I move the value in P0 to the accumulator register. Then we multiply by 12. That should multiply the value that's in the accumulator register. I don't know how high that goes. And then we move the value from the accumulator register to P1. And I can show you the simulation. And yeah, it looks like maybe we're not granular enough. So if we reset and step, okay, so that's 1 second. So those blocks are 1 second. And our expected was 50 and our actual is 100. Well, let's see, we start off by taking the input, 25. I don't think we're supposed to multiply by 12. That's way too much. Because it's maxing out. I'm going to go back to the email. Yep, just write it right into the chip. Oh, nope. It's not there. Let me open the design. The signal should be multiplied by 2 and copied to the controller out. Okay. Yeah. 12 did seem too big. So let's simulate that. That looks much better. Okay. I don't know when it's done. So I have to go through 3 times. Cool. Great. Let's go back to the email. Looks good. Thank you. Take care. Yeah. And new emails. All the parts. From Carl, our helpful colleague. Now that you're up and running, I figure it's safe to let you use all the lovely parts we have available to us. Just be warned that not all of them are going to be useful, whatever you're doing immediately. Cool. More parts. Now we have a pulse generator. A diagnostic pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements. However, instead of buying one at the market price, I thought we could simply create our own. For this project, you will need to make use of a conditional execution. Please continue your study of the language reference. Okay, cool. We get to use conditionals. Well, let's open up the concept. Okay, button is simple input. Pulse is a simple output connected to an electronic device. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. Okay, the button's pressed. We just pulse every second. Okay, so we'll need a loop of some sort then. And that loop can have like a conditional jump. And as long as that conditional remains true, we just keep jumping. Okay, let's use the same hardware, same board we did last time. Okay, so loop, we need a label. Wait, invalid instruction? Or can we just call it loop? Loop is our label. Okay. Loop is our label, and it's just sleep and move 100 to the output. So we'll make P1 the output, P0 the input. So we sleep for 1 second. Or let's start by moving 100. So move 100 to P1. Sleep 1 second, then move 100 to P0, and then sleep another second. Yeah, that seems fair. And then we jump to that label. Yeah, these games are really cool. Did anyone ever do... Oh geez, well it's the one with the hexagons, the hexagon machines. The alchemical machines. That one's really cool because it's not like, you know, they're still machines. They're just not based on anything in our world, but still something fun to play with. So let's look at our conditionals. So there's a test instruction and plus if we're going to do that. So where's our jump commands? Jump to label. So we're going to have something like a plus, jump to loop. And I think it's fair to check that. We could check that at the end of the sleep, maybe. I'm not sure if that'll get us in trouble if we like. No, I don't think it should. I guess this could be the on loop. We have multiple loops because otherwise we're still just gonna loop in a different loop. So we're gonna jump to on, and we have an off, and of course we still need a test. So off is just gonna sleep 1 second, sleep 1 second, and then we don't have enough space here. So if you want more memory, we just get a bigger chip. Okay. Alrighty. We still want to use P0 and P1. So here we sleep 1 and then we conditionally jump back to off. Else, so jump to off. Otherwise we jump to on. And here's going to jump to on. Otherwise jump to off. And now we just need conditionals. Oh, sorry. I'm gonna have to get used to this. Right, so bigger board. Bigger board means you can write more code on it. And I've got my on loop, my off loop, and jump instructions, and now I just need to figure out, let's learn about some conditionals. Okay, so we have our arithmetic instructions. You've already used those. Let's look at our test instructions. So test if equal. Test the value on the first operand is equal to the value on the second operand. And the button just goes all the way up to 100, right? So we can do a test if equal, test greater than, less than, and it just enables or disables the plus or minus. Let me see that again. Test equal. Test is equal P0 to 100. Oh, here I meant to move this to P1. And if it is equal, then we jump back to the start of the loop, the on loop. Okay, and then otherwise we end up in off loop. We kind of start. We should probably start in the off loop, right? I'm just gonna toss in a jump to off here and see if that works. Jump to off. Off loop, we just sleep. And as long as P0, so test equal P0 to 0, as long as P0 stays 0, we keep jumping back to off and sleeping for 1 second. Okay, let's give that a shot. Yeah, part not on a board. Oh, we can delete this. There we go. just staying on the whole time. So let's reset that and let's step through. So we jump immediately to off. We are looping through there. Off. Okay, now this test should fail, right? So since a test fails, we jump to on. Cool. And in on, we're moving 100 to P1. And we sleep for 1 second. And then we move... Oh, we forgot to move 0. We forgot to do the actual pulsing. So we move to 0 to P1. Okay, we're out of lines of code here, so I'm gonna delete this jump off I started with. And I think I'm gonna need to move this to the start. We'll start in the off loop. Okay, jump off, else jump to on, right? And we still need to move 0 to P1 to the output. Okay, let's simulate that. And we're still getting the same thing, but we're at least in the right part of the loop, so the main structure is working. Okay, so we're in the off loop, and the button is now pressed. We detect that and we jump to on. Okay. So, we move 100 to P1, okay. And sleep for a second. Oh, whoop, I have too many lines here. Let me back up on there. Move 100 to P1, sleep for 1 second, move 0 to P1, and then sleep for 1 second. Okay, let's try that. There we go. There we go. Easy peasy. Alrighty. Lines of code 11. Okay, and I'm guessing this histogram, that can't be showing the number of lines of code other people do it in, because who does this in 2 lines of code? Thank you, thank you. There's no way this can be done in 2 lines of code, right? I suppose I could also have one major loop, and then choosing whether I pulse or not. We could have a jump to pulse. Yeah, we could do a test for if the button is off, and we jump to pulse. But I guess mid-pulse, we still do need to... I think it's fine to have 2 full seconds in the pulse, because the second half, if we're still in the wrong loop, right, it doesn't matter, because it's 0 in both cases. Okay, those really are the stats. Someone's doing this in 2 lines of code. Well, we can definitely do better. So let's make a pulse that we can jump to. So a pulse is gonna be, well, let's just delete all of this actually. We'll relabel on. Pulse, move 100 to P1, sleep, and move 0 to P1. And then after the pulse, let's see, I suppose we could have a sleep command here, a sleep label. Okay, so we'll always sleep for 1 second. So we can do a test equal. So if P0 is 100, so if the button's pressed, then we can jump to pulse. Otherwise, we jump to sleep. How's that? That's at least better, right? Yeah, that's much better. Can we do even better? You know, I suppose we could always push. Oh wait, no, there's an error in here because it starts with the pulse. We should start on sleep. I suppose we can jump to sleep. So we start it in the sleep, and we jump back to the sleep as long as it's 0. Otherwise, we fall into the pulse. So let's try that. Okay, so that should at least do it. I think it can be simplified. Yeah, that can definitely be simplified. But it's at least correct. We only need one jump statement. Okay, we'll continue editing. And let's jump to sleep if it's negative. Otherwise, you only need to jump to pulse because pulse is just next already. And we'll just go back to the beginning, back up to the top. Cool, let's try that. There we go. That is much better than what we started with. There's 0 to P1. All right. Lines of code. Now 6, best 7, previous 7. I'm sure we can trim down another line. At least one more line, maybe 2. Actually, hey, we can trim one line down right now. There we go. We had white space. Wasting precious company resources. So jump back to the sleep. I wonder if there has to be a minimum of 2 sleep commands, right? Does there? Because we have to sleep once before testing each time. We have to sleep after doing a 1-second pulse, right? Okay, I think that's good enough for me. Well, I'm liking this game so far. I see how you could easily go into a rabbit hole of like continuing to optimize a circuit. Okay, it looks okay, suitable for our purpose, and we have 3 new emails. Sure. Take an orbital selfie. Trips start at just R89999. R? R is the currency? Is that rubles? That's Russian. Your adventure. Experience the stars and Earth as you've never seen them before. Enjoy the surprise and delight of our true weightlessness. And of course, take a picture of yourself that nobody will soon forget. There's never been a better time to take a trip to low Earth orbit. This feels like spam. Demand is skyrocketing and prices are cheaper than ever. Now's the time to get in on this trend, which has been popularized by international superstar Cool Dad and many others. Alrighty. Okay, lighted signs. So we have an animated esports sign. And what is this other email? Product, drinking game, Scorekeeper. Create a working design for this product. Okay. No, we're not doing an all-nighter. You're being responsible. Only staying up until 2 a.m. at most. I think I'll keep a regular slot, late night slot on Mondays. 11 to 2, maybe as I adjust to normal hours and unfuck my sleep. It'll be kind of like 10 to 1 or something. Of course. There's no way I could have sustained that. But come next Advent, you're refusing sleep again. Okay, let's try this. Fair enough. It begins. I got an incredible deal with major esports personality, the Sold Steel Gamer. Her team's contracted us to make light-up signs that actually animate for her fans. Cool. As long as you can keep the cost down, they're going to want tons of these to hand out at matches. Okay, just a few states. I feel like G coming in to say it's simple is I feel like he's the kind of guy that thinks everything's simple. So I don't think that tells us anything. Okay, so click 0 and 1 are simple inputs connected to display segments, corresponding to a clicking animation. Drink 0, drink 1, drink 2 are outputs. Okay, 2 inputs, 3 outputs connected to display segments, corresponding to a drinking animation. Okay, fixed repeating signals is indicated by the verification tab. Wait, click 0. Oh, it is all outputs. Okay, no inputs at all. Everything is fixed. Alrighty. So, click 0 and 1 are always opposite of each other. I'm wondering if I can kill 2 birds with 1 stone with an instruction there. Drink 0. Well, the drink signals all share a period. 1, 2, 3. What's this? 6 of 9. We could do this with 2 tiny chips, 1 for each of these. Right, let's take a look at the drink first. First we sleep for 6 seconds. Well, we have to do the 3 outputs actually. So we move 100 to P1. Oh, hold on. This chip only has 1 output. So we have 5 outputs. I don't want to use 4 chips. Or I don't want to use 5 chips. Let's check this. Okay, it's still just 1 output. Well, hold on. A pin is input or output, right? So this actually has 3 outputs. These both have 2 outputs. P0 and P1. Yeah, those pins are bidirectional. Let's not forget about that. So let's do a simple one first. So P0, we'll do the clicks. I wonder if I can rotate these. I guess we can't rotate them because we can't type vertically. space. Okay. Okay, so we're gonna move 100 to P0, move 0 to P1, and then we sleep for 1 second, and then we do the opposite, move 0 to P0, move 100 to P1, and then sleep for 1 second. Okay, let's try that part out at least. Cool. Now for part 2. I think maybe I can lump drink 0 and drink 1 onto one chip. And then drink 2 can be its own chip. I feel like using 3 chips is not what we want to do here. It says 4x outputs. Let's see. Bridge. Note. Interesting. I'm gonna check out the hardware manual real quick. Okay, so the MC400, this is our, or 4000, this is our default, the one that we used for the click lights. 9 lines of program memory, 1 register, 2 X bus pins, 2 simple I/O pins. Okay, MC6000 is just a bigger version of that. How many lines can it hold actually? 14 lines. X300 digital I/O expander. So this has 3 outs. Read or write up to 3 on-off signals at once. Hey, I think this is our chip. At any given time, the X300 is either in input mode or output mode. Okay, usage, write a 3-digit number to any X bus to change the state of the simple I/O pins. Oh, okay. So you have to write to the X bus. Read any, and then there's the read mode. Read any X bus pin to get a 3-digit number that captures the state of the simple I/O pins. Okay. So if we were to use this, we want to use the write mode. Representing the state of simple I/O pins. The value in the ones column corresponds to P0 while the tens P1. Okay. I see. So the X bus is just going to be a 3-digit binary number. And then the high bit goes to P2. I don't know. I don't think we're going to use that. It's not even in the recommended list. But I'm curious about the bridge because it is in the recommended list. That one has RAM. Bridge. X not found. You know what? Let me pull up the table of contents. There should be a bridge in here somewhere. Oh, is the bridge just for cables? Okay, never mind. Makes sense. Let's get rid of that. I don't know what this clickpad is. Note. Let's look at note. not seeing that. Okay. Well, we'll do one of these. I think we'd probably use a smaller controller. And now this is a 9-second wheel, alright? So it's, we'll do drink 0 and drink 1 together. So let's move 100 to P0. P0 will be our drink 0. Yes, and then move 0 to P1. And we sleep 6 seconds. Then we move 0. Well, we have enough instructions. Move 0 to P0 and move 1 to P1. And we sleep 1 second. Yeah, it's not gonna work. I really don't want to use 3 shifts for this. I imagine we could be clever about using accumulator, and depending on the values in there, that's gonna be too many lines of code actually. Okay, well, so drink 1 has 2 humps, so that's gonna take a lot of switching back and forth. So I'm gonna put that on its own chip. I'm gonna combine drink 2 and drink 0. Okay, so if P1 is going to be drink 2, I guess the bridge will come in handy here. So P0 is going to be drink 0. P1 is going to be drink 2. So we start with 0 and 0. Or 100 to P0, 0 to P1, okay. Sleep 6, and after sleep 6, only P1 will change. So move 0 to P0, and then we sleep 1 second. Sleep 1 second. And we move 1 to P1. Sleep 1 and sleep 1 and then moves 2 seconds, so it's up for 2 seconds. Move 0 to P1. And we've maxed out our lines of code. I'm gonna guess a bigger chip. Okay, and let's check that this bridge can actually, that bridge cannot cross. Okay, let's move it over this way then. You can cross over that way, no? So this needs to go up just a little bit. And this gets connected to a third chip. Okay, well I suppose 3 chips is better than 5 chips. So we sleep 2, move 0 to P1. And then we sleep 1, and at this point we move 100 back into P0. So that is back on. Yeesh. And this one's here is pretty simple. So for instance, we're drink 1. We're gonna do move 100 to P1. sleep 6 seconds. Move 0 to P1. Sleep 1 second. Move 100 to P1. Wait, no. We start at 0. 0 to P1, sleep 6 seconds. 1, we're peaking at 1 for 1 second. And that's 0 for 2 seconds. Sleep 2. And then move 100 to P1. Okay. And sleep for 1 second and restart the week. Let's give this all a shot. Okay, drink 2 is not doing anything. So I think I'm misunderstanding how the bridge works. I mean, I suppose I could always just move this up. That'd be in the manual, right? By the way, someone in chat was asking about Lean. Has anyone used Lean? It's a theorem proving language, kind of similar to Agda. Yeah, it's been on my list for a while, and I just opened up the book. I started reading through the first couple of chapters and going through some examples. Yeah, Lean 4. Let me see. Let me just pull up a website. Language. Is the music a bit loud? Yeah, thanks for letting me know. Let me turn that down a bit. Okay. Yeah, absolutely. So I started thinking about that because of the Ackermann function optimization, and I don't know. So I figured out patterns, right? I figured out patterns, and then I generalized those patterns. I don't actually have a proof that those patterns are correct, but it'd be nice to go about that in a more principled way and have that kind of thing in your back pocket when you need to actually do some math. Have something that's meant for, because what I'm basically doing is like editing comments line by line, and simulating like doing algebra on paper. But something like Lean seems like it's actually meant for doing math, right? So I don't know, I started reading that because I thought it might be interesting and it'd be nice to have in my back pocket. It overlaps a little bit with a couple other books I've on my list. I have a copy of Idris, the Idris book, Type-Driven Development, and of The Little Typer, or not The Little Typer, The Little Prover. Yeah. I mean, I suppose for the case of Ackermann, you'd have to prove it from the definition of the Ackermann function. So that might be trickier. It's certainly harder than just noticing the pattern and being like, okay, here's a pattern, let me generalize it. As far as I can see, it works, right? Software Foundations, which uses Coq, Oh, sure, yeah. Could you pull up a link for me for that? The Software Foundation's series of books. I see. Yeah, I'd love to dig into that. So what I was going through the manual here, looking for the bridge. Cool, thank you. Yeah, the little prover, it's from the little series, like the little schemer, the reason schemer. I really enjoyed the one on logic programming. Okay, I'm gonna put up this manual and I'm gonna give up on this bridge. What I should do instead is just, yeesh. I'm just gonna put the small chip in this space. And eventually we'll figure out how to use the bridge. Okay, so we need space for P1 to connect this way. And this P0 can go down there. That should work, right? Yeah, skip and ask ChatGPT for my Snickor proof, but no, the point is to have the tool. Yeah, prep for when GPT fails, exactly. But also, ChatGPT is not so great right now at proofs. I mean, if it's like a really common proof, sure. But I remember giving ChatGPT some logic puzzles. I have this book, To Mock a Mockingbird, that has a lot of really fun logic puzzles in it. And a lot of them are like truth teller and liar puzzles. And it can't solve those. It completely confabulates, and it's totally, I don't know, it's just totally hallucinating answers. And then you explain to it what the answer is and why, and it will like agree. Yeah. Like if an LLM knew how to use a theorem prover and model, you know, like first order logic and propositions or something like that, then it'd be nice if it could recognize a logic problem like that and then drop, you know how like it drops down into coding mode to do math, so it's not as bad at math anymore. It'd be nice if it could drop into a theorem prover and use that. Until that exists, we need to use our automated theorem provers by hand. Did I run this? I meant to run this. Oh, pin type mismatch. Oh, nope, we can't do an X there. We need a P1. There we go. Hey, drink 2 is not working. Drink 2 is connected to P1 here. Oh, move 1 to P1. That should be move 100 to P1. A lot of time, even after I tell it, the actual answer tries to stay in denial and tell you, yeah, I know. Hey, okay. I'm actually pretty average. I felt like I would have a lot of lines of code. And the cost? Yeah, I suppose multiple chips is necessary. Right, we have 4 chips and 6 outputs. So you do need, I mean, if there's 2 outputs per chip, you do need a minimum of 3 chips, don't you? Okay, I will live with that. And back to the email. So we still have a previous one here. Bring out the Baron, the drinking game scorekeeper. The Baron von Schnaps is the in-house is in the house, y'all. I was out drinking last night and met someone from the company that owns this brand. There's a drinking game they're promoting that's hella fun and off the rails. I made a deal to supply them with little personal scorekeepers they can give away at their events. Wait, that's the game? What counts as a point? What would be a foul? Surely not individual drinks. And he doesn't remember the rules. But we have a counter. Okay, so maybe we do a little bit of arithmetic now. Oh, cool. We have a segmented display. Points and fouls are simple inputs connected to buttons. Okay. We finally use an XBus. Displays an XBus display output corresponding to the numeric LCD screen. The counter should keep track of a count starting at 0 and ensure that the display is always showing the current value. When point is pushed, the count should be incremented by 1. Okay. So I think we might need 2 chips here because we only have 2 registers, right? So a chip for storing each of those. And every time it's pushed, we increment count. But the XBus, there's only a single XBus, so we need to combine those inputs. With another chip. And I think we'll need to check the documentation on the segmented display. Let me check out this paper you're mentioning. And you know what? Let me see, I can show just Firefox. Firefox isn't on my screen, is it? Here we go. Okay, the illusion of thinking. Understanding the strengths and limitations of reason models. Okay, that'd probably be useful to go through then. But, what was I going to show you? I pulled up the browser for a reason. Oh well, it'll come back. So the parts. We have a segmented display. So we have the controllers. Oh, note values. Ooh, that's cool. Push button controller. Here's the segmented display. Okay. Oh wait. This segmented display is just gonna be one number. Okay. I still think we need the 2 registers. Oh, we don't need the 2 registers. We can just increment or decrement 1 register. Cool. Cool. Let's get rid of these. We do need 2 inputs though. Yeah, I guess both of the P's can be our inputs. So P0 is going to be a foul, P1 is going to be a point. So we can sleep every second. So start by sleeping. And if we have one... I'm not going to handle the case where both are pressed at the same time. Unless that shows up in our simulation. Yeah, it's only just one or the other. Cool. Oh, well, I had to sleep at the end instead, actually. So, check if equal. So, what is it? Test equal. EQ. P0 to 100. So that's a foul. And in that case, we do ACK +1 or add 1. Otherwise, we subtract 1. Am I doing that right? Oh, sorry, I wasn't showing my screen again. But yeah, one ship will probably do this. I need to look back at the language reference. Let's see, program structure, conditionals, arithmetic. All right, add or sub 1. Yeah, cool. And then we sleep 1. Sleep for 1 second. So let's try that. Let's actually wire that out. So I suppose regardless of if we add or subtract, we will output. So we're going to move accumulator to X1. Cool, and we wire that to the display. And let's simulate. Oh boy. Yeah, so I'm misunderstanding the display. Okay. Seven, 2.5 digits, and bonus minus sign. Displays the full range of X plus values. So it should just display what is being pushed to it, right? In that case, what is going on here? Oh, it's step through. Oh, hold up. We didn't actually test the other button. So let's back out of here. We need to test test equal P1 to 100. And for that test, we sub 1. Okay. So I suppose if both buttons are pressed at the same time, nothing will change. I'll just run the simulation. We're negative. Negative instead of positive 12. So P0 is the foul. Okay, yep, that's it. So P1 should be adding 1, and P0, there we go. That looks like it's working correctly. No, it's not. Well, let's reset and step through. So nothing happens at first. Wonder what advanced does. Oh, like a whole loop through. So anyway, it went to -1. We had a foul. Oh, if we're at 0, we're supposed to stay at 0. I see. Okay, let's add that logic. I suppose we can nest tests by doing another test with a plus in front of it. Okay. So only if a test greater than. So ACK needs to be greater than -1, greater than or equal test GE. ACK 0, greater than or equal to 0. Make sure it's positive. Okay, test greater than is not a valid instruction. Let's look that up real quick. Conditional execution. What are our test instructions? Here we go. Whoops. Test instructions. Test greater than, test less than. Compare. Compare is just greater than. Okay, well, we can test if it's greater than -1. So test greater than -1. Okay. Oh, we went to -1. Oh, is greater than actually greater than or equal to? Oh, you know what? I suppose we can get a greater than or equal than by testing not less than or something. Okay, let's double check this. We have we want ACK. Let's test if ACK is less than 0. So test less than. Test if A is less than B. Okay. Test less than. Check if ACK is less than 1, I suppose. Or ACK is less than. Yeah, and if that's not the case, then we can sub 1. So we put a minus there. Okay. Oh, hold up. We are subtracting every time. The first operand is less than the value of the second. Okay, we want, let's go back to, so we want greater than or equal to 0. Which means, so we want the ACK is greater than or equal to 0. And instead of that, we could write, ACK greater than or equal to 0. We could write, you rewrite that as zero is not, because we can't actually write greater than. So we could write 0 is less than ACK. 0 is less than. It's not the case that 0 is greater than ACK, actually. No, because then if ACK is it should never be the case that 0 is greater than ACK, but also it should never be the case that 1 is greater than ACK, right? When we're running the sub1 instruction. Okay, so test greater than 1 ACK. and then we can have that with a minus. Wait a second. So at this point, oh, we skip over. Oh, I see what's happening. So we skip over that test, but we jump right into the next command, which we also want to skip over. Right. So that's not how we do a compound conditional. I suppose we could do a test that it's negative, and if it's negative, we just set it back to 1. So yeah, let's do that. That's the simplest way to think about this. Excuse me. So test square then 0 is greater than AC, and if that's the case, we will do I don't know, AC move 0 to AC. Sure. And now it's not advancing at all, so here we go. So we add 1, right? So AC is now 1. Cool. Then we step to do that sub. Oh, that should be a plus. That should be a plus. Those are all plus conditionals. There we go. Sorcerer, hey, Happy New Year. Good to see ya. And we're only allowed 1 more line of code. It's still not correct. It's actually going down. It seems like it's not going down. Yeah, that's the case. So I'm gonna skip ahead until here. And okay, so we've still got 7 going out. Now at this point, we loop around. We test if we are we test our file button. So our file button's not doing anything. Wait, P1. No, P1's our point button. Yeah, we test our point button. Okay, we test our file button. Great, so now we should be subtracting. Okay, so we went from 7 to 6. That's cool. We didn't reset to 0 because we didn't go negative. And now we move 6 into the display. Oh, hold up. I think the spec actually says we'd lose 2 points. 7 down to 5. Yeah, 13 down to 11. I see. We'll find Arduino. That sounds like a fun hobby. I want to have a full-on workshop with like a 3D printer and a bunch of things to tinker with. But that's not the time yet. I like the idea of just streaming from a like basement workshop with like a pegboard behind me, and cameras ready to work on like actual physical projects. I've thought sometimes about like live streaming lockpicking with like a cutaway pick or something. There's only so much you could do with that, though. There's only so much to explain. But, you know, to be able to show any kind of physical project would be nice. Okay, so our issue here is our subtraction. We should be subtracting 2 every time there's a foul. Alrighty, now let's try that again. Okay, we finally got it. And honestly, 6 lines of code seems optimal. I can't really... Yeah, no one's doing in fewer... Wait, lines of code 8? Okay, 8 lines of code. Cool. There is less power usage elsewhere. Not sure how to optimize that. That'd be fun. Oh, but what I'd really like to do is take do like FPGA stuff. I'd like to take, say, like an actual architecture and implement it. Okay. If you can't remember the rules of the game you were playing, how sure are you that you actually made the deal? Because they sent us a case of a variety of flavors. It's very tasty. Come try stuff. It's already too late for me, but you can still save yourselves. Heed my warning. Do not drink the Baron von Schnaps. Bye then. See you in the next life. Alright, no drinking games for us. Yeah, it sounds like a fun project, doesn't it? When I finally do the Rubik's Cube project on stream, I mean, I'll have my Bluetooth Rubik's Cube. It'll also be nice to have, like, you know, the actual cube. With, maybe if I get a green screen mat, I could have it here where my keyboard is, and you know, explain what's actually happening on an actual physical Rubik's Cube too. Self-driving cars stuck in a loop. You may be entitled to a settlement. Oh boy. Class action lawsuit. Wow, that has nothing to do with our company. Infrared sensor, important. Wait, we still need to do the rubbish audio thing. Harmonic maximization engine? Sounds fancy. So a contract comes in to build a piece of audio kit. Sounds fun, right? I always liked audio. The client promises that their little box will deliver crisp, high, and booming lows, all in perfect balance. Then I see their advert happen to include the much vaunted algorithm that powers this thing. Go take a look yourself. Oh. I should mention I put a copy of said advert on your desk. Just look in the pile of papers marked supplemental data, since that seemed most appropriate. I should also mention that we will still have to do this, as sad as it is. Looks work and all, even when you have to help a dodgy American company market rubbish shit like this as a premium kit for audio files. Oh no. Alright, this is where all the nameless Amazon companies come from. So what did he say? It was in our supplemental data? Harmonic maximization engine. At the Sunnyvale Institute for Audio Engineering, we have done decades of advanced audio research. Yada yada. There was no small amount of trepidation when our scientists in the lab introduced us to something they've been working on for the last few years. Would this be just another piece of audio gear destined to gather dust and okay, yeah, marketing fluff. Yes, the sound is really alive. And there's a formula. Won't like we're showing it to you, but go on. Have a peek at the proprietary harmonic maximization formula. Audio out equals audio in minus 50 times 4 plus 50. Okay. Sure. Well, let's use that. Fourier. Audio in, audio out, and maximize is connected to a switch. Okay, applying the maximization algorithm when the maximize switch is on. Okay. So we can just move audio in to an accumulator. And if maximize is pressed, then we do the formula. And otherwise we like jump out of there, jump past the formula to where we just move it to audio out. So this could be pretty simple. So move P0. I guess P is fine. Is P gonna be fun? What is our controller? It's a simple output. Okay. So move P0 to AC. Pin is not correct. We'll connect it in a bit. Let's connect it right now. So P0 is audio in. P1 is audio out. Oh. We don't have enough pins. This one here? P1, P0, we still only have 2 pins. Eesh. I suppose we could output it on an X pin. I suppose we could like have a switch that chooses between like a maximized chip and a normal chip. Well, let's at least implement the algorithm because we'll need it somewhere. So we take minus 50 times 4 plus 50. Okay. So sub 50 times 4, add 50. Mul 4, add 50. And then move Act 2 out. And I don't know, do we have a switch somewhere? Or move back to P1. Can we use an X1 pin? So if everything has even if we were choosing between 2 different inputs to go out, we would still need 3 pins. So I suppose that's not our approach. What if maybe we combine audio in and maximize into one input using a chip? We could have it be like 50 versus 100. Yeah, I think that makes sense. So we have an audio in. Oh wait, that's still 2 inputs and 1 output. I suppose we could use an X bus. that could go out on an X bus. I don't know, that seems excessive. Okay, so if x0 well, okay, we still need the audio in itself, right? Like it's gonna be some value. We need the full value of that. So I don't know that we can combine it with maximize unless we're like adding a whole 100 to it or something like that. So we could either be adding or subtracting 200. And if it's negative, then we add back 200 before No, I don't love that either. Okay, well, maybe we could take the audio in and we could have two X buses going out into another chip. And that just has the maximized value and the normal value. Right? And then the other chip that has that those two X values going into it can just choose between those two based on maximize. It feels like probably more energy than we need to use, but it'll at least get the job done. Yeah, let's try that. Open, right. So audio in here. So x0 is going to be the normal value, and x1 is going to be the maximized value. And that can be decided based on... Oh, I think I'll have to actually use a bridge now. I hope that's right. Okay. So we do a test based on P0 then. So test equal P0 to 100. In that case, we're doing the maximize. Or you know what, let's check if it's 0. We'll check if it's 0 because I want to jump on this. So in this case, we'll jump to back out. We'll do 100. So we'll have two labels. Jump to max Otherwise, jump to in, just a normal in. And for max, I'm gonna have enough space. We don't need to jump to max actually, because we're not doing the math in here. Let's see, if x0 is going to be the normal, we want to move x0 to p1. And can we actually do that? Let's make sure we can actually do that. I suppose we could do a quick test. We can just do a quick test in here. So we're just gonna move x0 to p1. Let's look at our audio, our normal audio in. So x0, yeah. So move p0 to x0 and sleep 1 second. It doesn't seem like that's illegal. We do need to get rid of this part. Okay. And that's blocked on read because it needs to sleep every 1 second. And every 1 second is fine. Okay, so in the case, if the maximize button is off, then it's very simple. We move x0 to p1. And while it's still positive, we would jump back to the start of the loop, right? Jump to start. And we could label this whole thing start. Otherwise, we move x1 to p1. And yeah, we just go back to the start. Or you know what? This can be actually a lot simpler. We can just make this a minus. Oh, you started using Scala for LeetCode. Cool. You're finding it approachable? Oh, I like hearing that. Right, this is a lot simpler than I'm making it. We do that. We sleep for 1 second. We don't even need a label. Are you running into any gotchas with the Scala? When I first started writing Scala, I pretty much wrote it like I would Python, except it had more Java-ish syntax. Before Scala 3 came out, 2020-ish, we had more of a curly brace syntax. Lack of a break for a loop. Yeah, that's fair. They really discourage, like, the closest thing you could do is like a return. But using return, like an actual return statement, is discouraged. I think what a return actually does is throw an exception. Iterator, lazy list, fine, take while, yeah. Yeah, the collections library is real nice. It's kind of like a Python iter tools. I was a heavy user of iter tools before I moved to Scala, so that felt natural. And I like that the collections library in Scala just all has the same interface. Okay, so we have a simple switch here. We either move x0 or x1. X1's the maximize, right? So we need to calculate x0 and x1. So to calculate x0, let's just move p0 to x0. Cool. And then we should also move p0 to ac. Then we do our add stuff. What is it? Wait, it was minus 50 times 4. So sub 50, move 4, add 50, and then we move ac to x1. So that's the maximized. And after that, we sleep. I think this blocked part not sleeping blocked on right. This will move something to x1. Yes. Oh, right. So we wrote x1. It's waiting for x1 to be used. I suppose I could move the thing that's not being used to ac. So move x1 to ac. And for the minus case, we move x0 to ac. Okay. I don't know. This feels very much like a hack, but like it should do the job, right? We're blocked on read here. And here we're blocked on write. Yeesh. D0 to x1. We can't write x0. X0 is not being used. Because this here is still blocked on reading the value of x1. But this reads the value of x1 on every loop of x1 and x0. You know, the tail call is actually pretty solid in Scala, the tail call optimization. So you could do like, you can do a for comprehension in Scala, and it's actually just syntax sugar. It gets translated to map, right? So like for x in 1 to 10 becomes 1 to 10 dot map. So it does function calls. And if those functions it's calling aren't inlined, then that is costly when you're micro-optimizing. But if you just do a tail recursive function, it will be as optimized as a while loop. It'll just use like jump commands. Sav, welcome, welcome. This is software for, well, I mean, we're playing a game. But in this game, I'm designing hardware that modifies an audio stream. It is a lot of fun. You know, I don't know if I can share the manual, because I was given a PDF rather than a link to online. I'll figure out how to share that. You found a use for take while in Python, but Python is not super functional friendly. Fair enough. Yeah, take while, drop while, and then span will give you both the both sides of that as like a tuple. And you can just rely on that in any collection. Okay, here we are always writing something to x0 on every loop, right? We're always writing something to x1 on every loop. This all went wrong when we hit maximize. So it's working fine for this bit. We're removing x0 and p1. And then once we hit maximize, then we go into this branch here. And here we're moving x1 to p1. Oh, I think we have to always use them in the same order. Yeah, that's what's going on. So move x1 to p1, and we're going to delete this line here. Okay, let's try that. Okay, so if you read and write from two x buses, you have to read them and write them in the same order. Tail call optimization might be nice for DB questions, because usually the recursive approach is easier to come up with. Yeah, except if you're doing the recursive option and you're doing memoize, and I think that memoize step is gonna. No, that'd work. You could put it in an if-else branch, and it would tail call optimize. Yeah. Yeah, totally. As long as it's not multiple recursive calls. Both branches, the calculate branch needs to be in tail call position too. Okay, so we use plenty of lines of code. Our cost is average, so you do have to use 2 chips. There's no getting around that, right? Someone did it with 1 expensive chip. Our power usage is high. Yeah, and that's because we are constantly calculating the maximize no matter what. Okay, it's hacky, but it works. I'll want to come back and optimize that. I see Black Deep. Hello, yes. This is actually my very first time streaming in January. I made it past December. I made it past Advent. Good to see you here. Someone was kind enough to upload a Shenzhen I PDF. Oh, thank you. Thank you for sharing that. Yeah, I'm still liking it so far. I suppose I don't have to calculate. I feel like I can't get around using the X bus though. Right, there's like there's 2 values that need to be considered no matter what. The audio stream and the maximize, and those will always take P's. So we have to have an X0. We have to have an X bus at some point. So I don't think we get around that. But we can get around calculating, I suppose. Like, one chip could decide what to calculate based on an input. And then another chip could just turn an X bus straight up into a P. We would need a bigger chip. Because the maximize operation takes a few lines of code. It always takes at least 3 lines of code here. But you know, if we're storing an ACK, yeah, we could have like a jump, a like skip command. We could skip ahead, and I want to try this actually. So let's try a bigger chip. We'll need more space here. So we could always start by moving P0 into ACK. And at the end, we always just move ACK into X1. So we only ever have one output. In fact, let's call that, we'll call that X0. No, we'll use X3. We'll decide it after we lay out our wires, right? So we'll always start by moving P0 into ACK, no matter what. And we will jump ahead to out, I guess. We'll label out. Or I don't know, we just do out colon. So test equal if our input, so our P1, which is going to be our maximize. So if our maximize is off 0, then we jump to out. Otherwise, we do the sub 50 mul for add 50, and then we just fall into out, right? And then now, this can always just be move X1 to P1. So we do sleep and move something to P1. Yeah, just convert the X back to P. Yeah. Oh, yeah, I suppose I just deleted that. So we're fully committed now. So we have an audio in P0. Can we move that tighter? No. And then we have the maximize P1. And then X3 just goes to X0. I don't like it that close together. And P1 goes right here. So we're gonna move X0 straight to P1 every second. Okay, I think we can be happy with that. Cool. That should minimize the amount of energy we're using. And it also does drop our lines of code. Our expense goes up. Our production cost goes up. So how many lines of code is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. If we can drop that down by 2 lines of code. So these 3 are necessary, right? There's a jump out and there's an out. There needs to be some test command. Oh, they can just be wrapped in pluses. Right, I keep thinking about blocks. I can make my own blocks. So this is minus, minus, and minus. Right? Then we can remove our jump command. Oops. Yeah, we keep our test. And we just make a whole block of minuses. Okay, we've unlocked a new technique here. So, okay, it looks like that's working. We can just copy paste that into a smaller chip. Alrighty. Why does this have so many X's? Oh, we don't want this chip. We want this chip. Yeah. Okay, so that's a small chip with 4 X buses. Okay, so we still have the P0 and P1 is still our maximize, right? And now our output is X1. Cool. And here, excuse me. X1 just connects to X0 over here. All right. That does it, that does it. Okay, I need to remember this trick of just using a block of minuses or pluses. That feels like a good breakthrough. I'm having to think differently to run this. Now I'm firmly average. This is the default solution. I think I will settle for firmly average. Holy crap, this thing is awesome. I hooked one of these babies up to my stereo at home, and the Bluetooth speakers clear off. Does the job, no question. Amazing. I like the snark. And so many more emails. So infrared sensors. This is really important design. And a little gossip thread. Note that I will be working remotely today and maybe tomorrow, just in case you're looking for me in the office. Oh, I assumed I was working remotely. I can work for a Chinese company from Maine, yeah? That's weird. I thought you got back from your trip yesterday. I did. I've been stuck in traffic jam on the way from the airport since... You've been in a traffic jam for over 24 hours? When the city grows as fast as Shenzen has, it's natural to expect that there might be some strain. I'm fine. I have food and water in here. Oh, eventually we'll be happy with any solution. Cool. I should just front load all the stupid, just make it work. We'll try to avoid being clever. A virtual reality buzzer. Hi all, apologies for the personal side here, but I met this wonderful girl named Shome, and well, to make a long story short, she's set to move in with me next month. That's just one small issue though, and it's something I thought maybe we could create a product to help with. See, when I'm doing my VR sessions, it's easy for someone to sneak up on me because I can't see or hear them. Awkward to say the least. This inspired me to think up a product, a simple vibrating buzzer that attaches to a VR headset so it can be felt even during the most intense sequences. Connecting that to the radio controller, I could place... this guy does Arduino home projects. I could place a button outside my study, and Xiaomei could buzz me when she needs me, with no chance of me being caught by surprise. What do you think? I mean... If you're playing a VR game, are you really that into it that, someone can't... I guess it could be dangerous to walk up to you, yeah? I'm sure plenty of other VR enthusiasts might find themselves in a similar predicament, and this is a solution inexpensive enough to be an impulse buy. Well, congrats, David. Note about the radio chip you'll be using. Normally, reading X-bus causes a microcontroller to block until data becomes available. However, this radio has a non-blocking X-bus buffer. Ooh, that's cool. the non-blocking buffer will immediately return a value of -999 when no data is currently available. Ah, that's nice. That seems less important than this one that's marked important. Oh, I'm in the process of setting up closer tie-ups with top global firms and working to secure higher profile work for our company. The first result of these efforts is a contract to create an infrared sensor. This allows us to participate in a booming market for passive monitoring stations to detect illegal activities. Illegal carbon emissions, illegal growing operations, illegal immigrations. If it gets against the law and generates heat, we'll detect it. Lovely. Okay. And a game idea. That seems complicated. Maybe we'll get back to that. Sometimes a decent product idea falls out when you're faffing about with chips and code and the like, so I've set up an empty prototype board for us to experiment on. Oh, so we just make some game. Illegal GPU. Yes. Okay. I kind of want to rebel. Like, just because this one's marked important, I want to work on this guy's VR buzzer so that his girlfriend doesn't sneak up on him. And I think that's exactly what I'll do. Okay. RX and TX, so receive and transmit, I guess. Radio RX is a non-blocking bus input connected to a radio receiver. Okay. Buzzer is a simple output connected to an electromechanical buzzer. When a data packet is received over the radio, read it and execute the corresponding command in the following buffer. Okay. So RX non-blocking input. We're not even using TX, are we? We're just receiving. Okay, so it's -999 when it's not receiving anything. When data is received over radio, execute the corresponding command in the following table. So if it's 0, we power off, turn off the buzzer, and if it's 1, we power on. Okay, simple enough. We'll just connect that directly. Okay, so test equal x0, 0. And in that case, we power off the buzzer, move 0 to 100. I suppose we could do another, no, not to 100, sorry, to P1, the output. And I think we need to do a separate test for 1, because it could be -999 if there's nothing at all. So test equal x0 to 1. In that case, we move 100 to P1. In either case, we sleep for 1 second. That seems like it, yeah? No, we're missing something. Okay, in this case, we finally get 1. And the value in x1 should be 1, or the value in x0 should be 1, but it's apparently still showing -999. I think I'm misunderstanding the radio. Okay, it shows 0. Wait, when does it actually turn into 1? Okay, here it's 1. Oh, hold up. If we read twice, then we've read the value. So we can only read that once. Does this chip have a predicate register? I don't think so. It has an accumulator, we could use that. So what we could do is on every loop, we move x0 to ACK. Then we test on the ACK instead. That should do it. We're not turning back off. Okay, so we'll advance until we hit the 1 case. Okay, so here there's a 1 in the input buffer. And we move it to ACK. Now we're testing ACK. It's not 0, so we're not going to do that. Now we're testing it if it's 1. And in this case, it is, so we should move. There we go. So that's fine. That's good. Now in this case, we still have -999. So nothing changes. But it remains -999. Oh, okay, I think if it's... Oh wait, the buzzing is a pulse. I see. We keep pulsing. So let's move to 100 to P1, sleep 1. We'll add a plus there too. And a plus, move 0 to P1 to finish the pulse, and then no matter what, we do sleep 1. Let's try that. Not quite, because we kept reading from the input buffer. Right, so we do that, we read from the input buffer. Right, we should continue. So on the next loop, we should just do that, unless we change our state. I suppose we could store the state in ACK. So if it's not 999, we put it in ACK. Then based on the value of ACK, rather than based on yeah, because at some point it's gonna be -999, and we're still testing for like 1 here to decide whether to continue our loop, and the 1 doesn't stay constant. So our ACK can be our switch. I'm gonna copy this code into a new chip. And I feel like we might need a bigger chip. Yeah, let's start with a bigger chip. We can always make it smaller if we need to. So we're gonna move x0 to ACK conditionally. So let's do a test equal x0 to -999. And if that is not the case, then we move x0 to ACK. We have found a new value, right? Great. And now we test if ACK is 0. And if it's 0, we move 1 to P1. I don't think we need to even have this test now because it's always going to be 0 or 1, right? So you can move this ACK. So in the negative case, we move 100 to P1, and then we also sleep and then move 0 to P1. You do a pulse. Cool. Let's try that. Oh boy. Okay, so now we kept on going. We never noticed the 0. So let's advance. Okay, so we start pulsing. It's -99 and we're still pulsing. Oh, we ended up with -999 in ACK. That was not supposed to happen. So if 0 is equal to -999, then we move x0 to ACK. We should never move it to ACK otherwise. Okay, I want to look at how -999 got into ACK. Where does it happen? Right here after the 1. Okay. Okay, so here there's -999 on the bus. We tested if it's equal to 0, or if x is equal to -999. It's not, so we shouldn't be moving in, right? And yet that happens. That perplexes me. We're all seeing that, right? It's the same thing, like I'm reading it twice. Oh, yeah. I assumed you could read as many -999s as you wanted. Let me just go back to the email. Normally, reading XBus causes the microcontroller to block until data becomes available. However, this radio has a non-blocking XBus buffer. Will immediately return a value of -999 when no data is currently available. Yeah, so when no data, there's a default value, right? So that tells me we can read -999 as many times as we want. Right? That seems reasonable. So we're reading as many 999s as we want, and only when it's not 999, which means there was data, do we actually move into ACK. Once you read something else, oh, okay, if you read something else. Okay, so you're saying like if we read a 1, then after that we don't read 999s? Okay, let's step through the simulation and confirm that then. Yes, you don't read the 1 again. That should be fine. Oh, wait. Yeah, we don't read the 1 again. I'm cool with that because I've already saved it to the accumulator. So I'm still, when I'm branching here, I'm branching based on the value that I saved to the accumulator. So I don't think I'm trying to read the 1 again. Okay, so in this case, Right, we didn't save the value. So we just move 0 to P1 because our default is 0. Right, and we do that again. Here we finally get a 1. You consumed it in T equal? Oh, so what? I can only consume ACK once, is what you're saying. ACK doesn't stay constant. I consumed it in the... Then you lost the 1 when you saved to the ACK. Oh, okay, I see. Right. The act of doing the test consumes it. The act of doing the test consumes it, so we can't move x0 to ACK if we've tested on it. Okay, so let's see that happening here then. It does have a second register. I should read up on those registers. Okay, but let's just confirm that behavior. So, there, we read the -9, oh, we read the 1, and then we're moving x0 to ACK, which at this point is a -99. Yep, you're absolutely right. That's exactly what's happening. Okay. Yeah, let's read about those other registers. State, exec, and power. Okay, there are registers. General purpose accumulator. It is a target of all arithmetic instructions. General purpose data register. I suppose we should be saving it in data because we're not doing anything else with it. Used for additional on-chip storage. I suppose they can both be used in the same way, right? They don't behave differently. And state is just telling us about at any time, simple IO is either input mode or output mode. Writing a value to a pin register will put the corresponding pin into output mode. Yeah. Okay, right. So we can only just move the value into ACK. Then we can access that value as many times as you want, including for tests. And then data is where we save our actual value. Yeah, that makes sense. So we're no longer going to test x0. That is dangerous. Instead, we directly move x0 to ACK. And then now we test equal on ACK if it's -999. And if it is anything other than -999, we're going to move ACK into data. Then we can test data and make our actual decisions based on the data register. Okay, let's give that a shot. There we go, that works. Thank you, Icy Black Deep, you figured it out. It's vibrating. Cool, that's not bad. I don't feel the need to optimize it. Wonderful, this is exactly as I had imagined it. Great. We made our coworker happy. Shenzen days, things visitors say. Okay, let's learn a bit more about Shenzen. Today I want to talk about the goofy things visitors here tend to say. Actually, just one thing. It feels like every time a certain kind of Western visitor comes to China and looks around, they go, "Wait a second, I thought China was communist." So why is everyone shopping at the store? What is up with that? And that's when everyone around laughs because one, the dude always thinks he is making some good observation when we've heard at least that one at least 1 trillion times before. And two, it's complicated, okay? What's important is that so many of these guys' impressions of communist China still come right out of the 1970s. And they're so surprised when they get here, like they had no idea that things were changing dramatically here this whole time in the last 50 years. Well, hey, you haven't been sitting around doing nothing since Nixon, and neither have we. And you built more than just the factories where all your smartphones and game consoles come from. Fair enough. The world is changing, fellas, and empty your mind. Don't cling to your fixed ideas. I believe in you, okay? Okay. It's kind of like how every time you watch a movie that's set in, I don't know, somewhere exotic, I don't know, like somewhere in the Middle East or Africa or whatever. It never shows like the modern version. It always shows the movie version. Great. This thread seems to be moving, prototyping new ideas. Let's see this. Oh, we should do the important thing, the infrared sensor. And Carl is asking for help on a project. Our projects are stacking up faster than we can do them. Okay, I'm in the process of setting up closer tie-ups with top global firms and working to secure higher profile work for our company. The first result of these efforts is a contract to create an infrared sensor. This allows us to participate in the booming. Okay, yep. Detect any kind of illegal activities based on heat. Illegal growing operations, illegal immigration, everything. Okay. What is this? Time is a simple input connected to a clock providing the current time. Oh my god. Speaking of time, you realize it's 1:45 a.m.? I feel like I've only been doing this for an hour, so this has definitely sucked me in a little bit. I'll make this my last one for today. And I need to sleep. I can't get too used to being up every night. Time is a simple input connected to a clock. You used Unfold for today's leak code. Oh, cool. I like Unfold. Sometimes I feel like often when I reach for it, I'm doing like gratuitously. But when you already have a function that's returning, that happens to return like an option of left in state, then it just works. Cool, yeah. I'd like to have a look at that. I don't usually do the day's leak code, but maybe I should make a habit of that. So sensor is a simple input connected to an infrared sensor. Alarm is a simple output connected to silent alarm. When the current time equals the on time, the device should be armed. Okay, where's time coming from? On time, off time. Whenever the device is armed, the sensor data reads at or above, and the sensor data reads at or above the value of 20. The alarm should be active. Okay. And what does the alarm do? It just is on to 100. We could start with the very end of that branch. Did Unfold for a breath for search. That makes sense. Yeah. There are a lot of things. There are a lot. On occasion, there are some things that you can do with either a fold or an unfold, or like an accumulate, which is scan in Scala. And I don't know. Sometimes choosing the right combinator is the trick. I think you could definitely do a breadth first search with a plain fold too. But it's a worthwhile exercise trying it with different combinators just to see which one looks the best. Then I can help you realize when it's better to reach for one over the other. Okay, so let's start with this end chip. And basically, if there are two conditions, so if armed and if sensor above value, how do we do an and? I guess we could have two jumps that go back to the start of the loop. So the start of the loop can be, well, there's a start. Or, we just call it the main, yeah, we'll just call it start. And we could have two tests. So the sensor's simple input. Arm can also be a simple input. Well, alarm is a simple output though. I was thinking we could have two tests where like if they fail, they jump back to start. So the first thing this does is sleep one. But we had the same problem we did earlier, which is that we have two inputs and an output, and we only have two of these normal pins. So one of them is going to have to be an X bus. And when it's an X bus, we have to be sure to sync up the reads and writes, which is really annoying. I just want to have 3 pins. Having more fun selecting combinators and doing the problem. Yeah, fair enough. Okay, I suppose I'll start from the left side then, and that will help me decide what should be an X bus and not. So is this thing here the clock? I need to look up that thing in the manual. So a DT2415? Okay. A Denver timekeeping incremental clock. Emits a simple I/O signal that corresponds to a number of 15-minute increments since midnight. Includes a built-in backup battery so time is kept. Cool. So we don't use this NC. Example output 0, 1, 2, 3, all the way up to 95. And that's a simple I/O. And the Denver timekeeping story. When Denver timekeeping founders Chad and Becca set up their small batch chip fab in the mountains of Denver, Colorado. Oh my god, it's like a what's the word? It's like artisan chips, like they're selling chocolates or something. There were many who were dubious, to say the least. You can't manufacture in America anymore, they said. It's too expensive, and hasn't all that expertise left the country anyhow? But Chad and Becca persistently stuck to their vision of inexpensive, reliable, and American-made timekeeping chips manufactured the old way. And after many trials and tribulations, they're proud to announce Denver timekeeping DT2415. made into cool air with the pure water of the Rocky Mountains. This real-time clock includes a backup battery that ensures the time is kept even when power is not. A must-have for the ruggedized devices. We hope you enjoy this chip, and if you're ever in Denver, drop us a line. Chad and Becca love to show customers around the fab. It's like single origin, fair trade, time chips. Oh, my camera's frozen. Yeah, let me give a look at that. Thank you for telling me. It's kind of a funny pose. All right. Timeshare time chips. Exactly. Okay. Well, anyway, the information we needed out of this was the index. It's just a simple I/O. Cool. The bottom one. And we don't use the other bits. So let's get a chip. Oh geez, and we need both the on time and the off time. Are these simple outputs? Or are they X? Pin type mismatch. Okay, those are X. X bus. Great. Because we need to save those chips. So this will compare then the current time, which is a P, against, I think we're fighting for space here. Against the on time and the off time. Okay, and we need a bridge. There we go. Connect that to... Okay, so this is our armed. So it turns on at 93. So basically, if it is less than on and greater than off in this case, oh no, we can just arm whenever it hits those time slots. Okay. And then on every loop, based on, I guess we'll use accumulator instead of the data register. So based on what's in the accumulator, we can choose what to output to P1. So let's test equal, time is P0. So we'll check P0 against on time, X0. And if it is in fact on, or if they do match, then move 100 into ACK. And we do something similar. Test P0 against X1. So we'll always consume one from those X buses, from each of those X buses. P0 against X1. Move 0 to ACK. Then we can test on the ACK. Or actually, we could always just move ACK. Move ACK into P1. And sleep for 1 second. Okay. Now P1 is the armed. And the sensor. Let's see. could have this go into the other P of this chip here. Maybe. And then the output can go into an X1, and then we can just convert that X1 into a P. Ah, that's so annoying though. I just would like to have 3 Ps. There's gotta be a way around that. Maybe this helps. Well, if we're gonna be converting to an X anyway, instead of an output, we could have 2 inputs. The other input is for the sensor, and we could put it all in one chip maybe. Right, and instead of writing this to the output to P1, we could move it to data. I'm gonna play around with that idea. Okay, let me just get that out of the way. Okay, so we move to data, and we're saying, okay, this is data means armed now. So now if data is armed, and I suppose P1 can be the sensor. Too bad we can't just do an XOR. Or like a multiply. We could do a multiply. To do an AND, we can do a multiply. So we won't sleep just yet. What we're gonna do is test we'll leave an armed comment here. Okay, armed. So we're gonna test if P1's gonna be our sensor, is equal to 100. And in that case, we can just move whatever's an ACK, our armed, to the output. Move ACK to, I guess, like X3 can be our output. Otherwise, we move 0 to our output. And then we sleep. Okay, so this is our AND. I think that works. And then now we just have a simple chip for converting the X into a P. So we'll hold on to that. I'm going to put this off to the side in case I actually still want it. Okay, so these two were X's. So X0 is our on time. X1 is our off time. Yeah, X0 is our on time because we're moving 100 to ACK. We do still want to use P0 though. When do we use? What was our P0 originally? It was a time that we're comparing against. So we'll need bridges. We need a long bridge. We could do a pair of bridges, I suppose, and have this go underneath. can bridges be horizontal? It doesn't seem to have a rotate feature. Well. I suppose we have to do a couple of bridges then. Geez, I don't like this. This feels messy. But we got all our inputs there, and now there's no room for the sensor. I didn't expect to be playing like a a space puzzle. Yeah, we need to get to P1. What if we send this one here to P0 and connect that one to P1? So we'll connect the sensor to P0. Okay. So the sensor is now P0. So our arm check here. And P1 is now our time. Okay. So here's our time. And then now X3 just needs to be converted. Yeesh. Can I move everything to the left a little bit? I think I can. Lovely. I guess this isn't so bad. Okay, so this ends in a sleep 1. So, it only conditionally moves 0 to X3. Oh wait, so we either move ACK to X3 or 0 to X3. Okay, so it's always pushing something into X3 on every second. Okay, so we can get rid of this. Now we just move X0 to P1 and we sleep for 1 second. Okay, well, it's not too complicated, it's just complex, or it's just long, right? In fact, simple alarm output. Well, seems like we're always doing a 0. So let's advance. Okay, so sensor. At this point, the sensor value should change. Right now it's 35. And what does information say? Oh, wait, we forgot to actually implement value. Whenever the device is armed and the sensor reads at or above the value of 20, the alarm should be active. Okay, so this is about to arm it because of the 93, right? Cool. And the sensor value has always been at or above, has long been at or above 20. So our sensor is P0. Right, so we're just testing if it's equal to 100. Instead, we suggest greater than. Test greater than 20 or 19, I suppose. Okay, let's try that. Hey, there we go. We only had one bug. But it is gnarly, and I hate having to change X into P's. Okay, and we're firmly average there. So I think that means we've reached like the natural solution. Alrighty. Just letting you know that your design for the infrared sensor component was well received by our partners and is set to be integrated into a number of products currently under development by various defense and security firms. Obviously, our performance here opens the door to more jobs of this nature, so thank you for contributing to Longtang's future as military contractors. Hang on, we're becoming defense suppliers? Yeah, defense suppliers. Oh. Lovely. Okay. Well, it is bedtime now, but I thought it's a good game. I don't know. I'd like to keep the theme on assembly if there's someone on Twitch doing that. So let's look for a raid. Good night. Thanks for stopping by and chatting a bit. Yeah, and I'm still thinking of those other projects. Maybe here soon we'll go into Nanta Tetra stuff, which will be really fun. I'm still kind of brainstorming how I want to approach that. And at some point, I might do a Cinecore follow-up because I want to put it on the web. Put like a little emulator console. So we might do some projects that are related. Yeah, I hope what I'm sharing is clear. That's part of the goal here, is to become more clear with that. Let's see. It is super chill. It's nice to relax after after the rush of Cinecore and Advent. It's nice to relax for a little bit. There's some game dev. There is messy lens stuff. Journey to be a data engineer. That might be fun. We have RimWorld at home. Oh, like making a RimWorld clone. Okay, so doing some web scraping. I never,
right? Because I want to be me. I just want to do the thing. Like I just want to stream. I just want to be this dude on stream. I don't want to play a character.
Thanks so much for the follow, Wadology. I
God, it sounds fucking miserable, dude.
Anyways, so we have the title.
It sounds fucking miserable. To run a stream that you don't even like.
Okay. Anyways, we have the
feel like like I don't know, man. Like, yeah. No.
And then we have.
No, thank you.
might be a bit of big.
I know there are streamers that play characters on stream, and I am all for them doing so, and like I hope they keep doing it.
Yeah,
but
definitely.
Couldn't be me. I wouldn't keep streaming if I had to play a character.
I know I've touched on it every now and then.
It's not worth it to me.
And for me, the biggest one.
I'd just make YouTube videos then.
Or like one of the big ones was doing Nanta Tetris. And that's partially because I was like
Coppinger plays characters. Let me put it this way. I believe Coppinger gets super fucking annoyed by some of his chatters.
And I was like, okay, I'm just gonna do independent
all
study.
the fucking time.
And it felt good to.
I don't have any evidence.
Just
I don't
choose
have
my
anything
own,
that like represents
choose my
this.
own
I
courses.
am willing to
Thanks,
bet
Nan. I appreciate
Coppinger
it.
is
Jump right into
super
it. I am
fucking
really
annoyed by his
curious.
chatters,
Really quick,
and he
guys.
just ignores them instead.
Okay, so
Okay.
I guarantee there are people that he wishes would just fucking stop talking.
okay, so I need to find
Right?
You know,
No, and I get that talented, but
this
I'm just gonna
frustration
point
thing.
out, like,
Passive the vibe.
come on,
Okay,
man.
so
Copపింger's
See what they're
only
up to.
human. I
Oh, you
would
can hear
bet
all that?
any amount of money that
Fair
there are
enough.
times where he's been like, holy shit,
I didn't think my
dude,
Firefox.
I don't even want
audio was
to
on.
be here anymore. Why
Oh
am
yeah,
I
yeah,
streaming?
it's definitely on.
Right? Like, I should just be building.
All right. I think TM Griffin's talking like streaming philosophy right now. Okay. We'll give a raid to Bunny Bites. He can't hear me at all. All right. Thanks for hanging out and sharing all your ideas. And you know what? During these Shenzen streams, I'm happy to take the aggressions. We can definitely chat more about those other topics. I've got a whole list of things that are interesting me right now. But yeah, I'll be around. Mondays are my slot now. Have a good one.